Today we're doing lesson 4.3. It's all about properties of isosceles and equilateral triangles. So your objective is to use the properties of isosceles and equilateral triangles. What do we know about equilateral triangles? What makes it equilateral? All the sides are equal. So we're going to be looking at triangles today where all the sides are equal. What makes it isosceles? Two sides are equal? Sound familiar? Alright, so we're going to be looking at first triangles where two sides are equal, and then second triangles where three sides are equal. Any questions before we get going? This is our last lesson of this week. We're reviewing tomorrow, and then you guys have Friday off. Alright, you guys need to copy this into your notebooks. These are the parts of an isosceles triangle. So important things to notice as you're copying this down, the legs are the two sides that are congruent. So to be isosceles, two sides have to be congruent. We call those the legs. We call the other side, the not congruent side, the base. And then we call the angles across from the legs, the angles that touch the base, those are called the base angles. While you have this picture, I would label the base angles as being congruent. You're going to learn that on the next slide. If two sides are congruent, the sides are the angles opposite those sides are also congruent. So if the legs are congruent, the base angles are congruent. Any questions on the parts of an isosceles triangle? Alright, this is basically in words what we were just talking about. So if two sides are congruent, then the two angles across from them, we're calling those the base angles, are also congruent. So write this in your notes. All right, here's how we're going to do these. We're going to do the first two together, the one labeled A and B. We're going to do those as a group. You don't need to write them in your notes. But then the 1, 2, 3, you will have to write in your notes. So they're sort of separate sections. We'll do the ones above this line together, and then we'll do the ones below this line in your notebooks. All right, so you just learned that if two sides are congruent, then the angles across from those sides, here and here, are also congruent. So if C is 82, what's A? 82. Good. And notice the directions say find angle A, so we're done. Any questions on A? Again, you don't need that one in your notebook. We're just doing it together out loud. All right, part B. These are the sides that are congruent. So what angles are congruent? The ones across, right? So that would be which two? B and C. So what is C? Yeah, C and B are the same. So this is going to be 67. But what do the directions tell us to find? A. Uh-oh. Do I know how to find the third angle when I know the other two? Yes. What do I do? Yeah, you can add them together and subtract them from 180, or you can just take 180 minus 67 minus 67 again, and that'll be your answer for angle A. So someone with a calculator handy, go ahead and do that for us. 46? All right, I'll take your word for it. Any questions on those first two? All right, I'm going to give you a minute to get 1, 2, and 3 on your notebooks. If you want to give them a shot, you can. If you want to just wait for directions, that's fine too. Just make sure that you're finding angle A when you're doing these. All right, let's go through these. So number 1, did anyone find the measure of angle A in number 1? Anyone? They're both the base angles. They're across from the legs. So what do I know about them? They'd be the same. Good. This one's going to be 45 degrees for A. All right. Anyone know how to find A in number 2? Is A one of the base angles? Across from those congruent sides? Yes, so you know that it's the same as B. Yeah, so it's just 57. Now, over here, is A one of the base angles? No, so I'm going to have to do a little extra work. I can right now, at the moment, find angle B. What's angle B? Angle B is 79. Good. How can I find A, though? 180 minus 79 minus 79 equals what? 22. Good. So again, when it's one of the base angles, it's going to be congruent with the other base angle. When it's not one of the base angles, you have to do that extra subtraction once you find the two base angles. And that's going back to what we learned yesterday. What are your questions on this? All right, now we're going to look at the converse of this theorem we were just talking about. Remember, converse, you just flip the if and the then. So now we're saying if you know that the angles are congruent, then you can say that the sides opposite them are also congruent. So we're just working backwards. And again, this is the converse or the flip-flop of that base angle theorem. Alright, so same as last time, we're going to do the top one together, and then you can do the bottom three in your notes. So, now I'm given that these angles are congruent. Using that converse that we just learned, I can now say that the angles opposite, so that would be the 18, and the 3x are congruent. Congruent means equal. So set them equal to one another. Solve for your x. Here I get that x equals 6. Any questions? Alright, you can go ahead and write 4, 5, and 6 in your notebooks. If you want to give them a shot in the next couple of minutes, that would be fine. If you want to wait for me to go through them, that would be fine as well, but just make sure you have them in your notes by then.
Yeah, for as much as he misses.
Alright, number 4, what are you guys thinking? If these angles are congruent, what sides are congruent? The sides across. What's across from this one? 2x. What's across from this one? 15. So we know that 2x equals 15. If 2x equals 15, how can I find x? Divide both sides by 2. Good. So x equals 15 over 2. If you type that in a calculator, it would give you the decimal 7.5. Either one of those is fine. If you want to leave it as an improper fraction, great. If you want to change it to a decimal, fine. I don't really like mixed numbers. It's just a personal preference of mine. So I would leave it in one of those ways. All right, what about number 5? So 38, because that's across from that angle, equals x minus 7. It's across from the other congruent angle. How do I find x? Add 7. Good. So what's 38 plus 7? So 45 equals x, or you could write x equals 45, same thing. How you guys doing on these? Good. Okay. And number 6? 27 equals what? 5x plus 7. Good. How do I solve for the x? Subtract 7 from both sides. 20 equals 5x. Then what? Good. So x equals what? 4. Good. What are your questions on this? All right, 2 more things to write down. They look very similar. Basically kind of saying the same thing, but in reverse. The first one is the equilateral theorem. It's saying if you have a triangle that's equilateral, then it's also equiangular. And then it works in reverse too. The converse works. We call that the equiangular theorem because you know that it's equiangular first. Then you can say it's equilateral. So I'll give you a second to write those down. Then we're going to draw a picture to go with them. So once you have them both in your notes, I want you to go ahead and draw a triangle. Label it equilateral. Then label it equiangular. They go hand in hand. Equilateral implies equiangular. Equiangular implies equilateral. Now, there's one extra thing I want to add to this. If you know that all the angles are the same, and we know that all the angles add to 180, does anyone know what each of the angles must be? You've seen a few of them already. So if they're all the same, does anyone know what they have to be? What would the measure be? 90 would give us too many. 60 is the magic number. If they're all the same, they would all be 60 degrees. If you can remember that, that's going to come in handy on a lot of these problems. So I would go ahead and put that in your notes as well. The only way for them to all be the same and all add to 180 is if they're each 60. And an easy way to do that is to think of 180 divided by 3, because they'd all be the same. You're breaking 180 into 3 equal parts. That's division. You'd have 60, 60, and 60. What are your questions on this? Just like the previous slides for today, we're going to do the first one together, then we're going to do the last 3 in your notes, and then we're done for today. So here we're given that this is equiangular, right? All the angles are labeled as being congruent. So what do I know right away about all the sides? If all the angles are the same, all the sides are congruent. So I'm going to set them equal. 6x equals 24. That's going to help me find out what the x is. And I'm coming up with x equals 4. Alright, I'll give you a second to write the next 3 in your notes. Then we'll do those together. And then you guys can start on your homework. All right, how can I start number 7? I know that all the angles are the same. What does that mean about the sides? They're congruent. So I'm going to say that 2x minus 1 equals 19, and I'm going to find x by solving that equation. What should I do first? Add the 1 to both sides. Good. That gives me 2x equals 20. Divide both sides by 2, so what's x? 10. Wonderful. Alright, what about the next one? All the angles are the same, so what do I know about all the sides? They're congruent, so I can set them equal to one another and solve for x. What should I do here? Subtract 5 from both sides. Good. So I get 7x equals 21. Then what? So x equals 3. Great. I'll write it up here. Kind of hard to see. Now, 9's a little trickier. They tell us that all the sides are the same, so I know that all the angles must be the same, right? But I don't really know the measure of any of them. Or do I? What did we talk about on the last slide? If all of them are the same, they all have to be 60. So we're actually going to use that to set up our equation. So again, when all 3 angles are congruent, they must all be 60-degree angles. So I can set 5x equal to 60. That'll help me find the x. How do I solve that? Divide both sides by 5. So x is going to be 12. What are your questions on the notes today? Alright, you should all have a copy of your homework by now. I want to do the first 8 as a group. So we'll be almost halfway done by the time we're done talking here. Alright, so let's do number 1. Number 1 says the congruent sides of an isosceles triangle are called... That first diagram in your notes will help us with this. What did we call the 2 congruent sides? Remember, we had a diagram. It was labeled like this. What word was here and here? What were those called? Those were the legs. Good. Number 2 says the non-congruent side of an isosceles triangle is called the blank. So what did we call this side? The base. The side is the base. You gave me the answer for number 3. The 2 angles at the base of an isosceles triangle, that's base angles. So the side is the base, the angles are the base angles. Number 4, if 2 sides of a triangle are congruent, then the angles opposite them are equal or congruent. Good. And then this next one comes from the converse. If 2 angles of a triangle are congruent, then the sides opposite them are equal. What's another word for equal? Congruent. Good. That's also congruent. And then 6 and 7 go hand in hand. Number 6 says if a triangle is equilateral, then it's equiangular. Good. And then number 7 says if the triangle is equiangular, then it's equilateral. Good. So one tells you the other. All right, then we didn't do any in our notes like 8, so I want to go through that one real quick as well. So you're starting with this triangle. Looks like this. It's labeled A, B, C. The directions say to tell which sides and which angles are congruent. So which sides are congruent? The legs, yep. The legs are AB and BC. So I'm just going to say AB is congruent to BC, and you can tell because those are the ones that are labeled as congruent. Those are the legs. All right, I also want to talk about which angles are congruent. So angle blank and angle blank are congruent. A and C, good. And we know that because those are the base angles. They're the angles across from the legs. So you'd say angle A is congruent to angle C. That's how you do problem 8. And you need both to get credit. Do you guys have any questions before I let you go on your homework?